In this problem, we have two boxes. These boxes are being pushed together, which compresses a spring. This spring will then push both these boxes out in opposite directions, and we need to find how much the spring was compressed. Well, I'll start with an energy equation. I'm going to assume that there's no air resistance or friction, so energy 1 is going to be equal to energy 2, where 1 is before and 2 is after. Before, the only energy is just the energy in the spring, so this will be 1 half k x squared. After, the spring will no longer have any energy, but both of these boxes will have energy. So it'll be 1 half the mass of the first box, the velocity of the first box squared, plus 1 half the mass of the second box times the velocity of the second box squared. Now, we don't know the velocity of the second box, but we do know the velocity of the first box. And we also know that both of these were at rest before they were pushed by the spring. So I'm going to use a conservation of momentum equation to find V2. Well, before, it'll be mv plus mv. Both of these boxes are going to be at rest, so those will be 0. We'll have the velocity of this first box. I'm actually going to say that this will be negative, and the velocity of the second box will be positive. So it'll actually be negative m1 v1 plus positive m2 v2. I'm going to add this to the other side, and I'll get that m1 v1 is equal to m2 v2. I'm going to solve for v2 because it's what we don't know. I'll get v2 is equal to m1 v1 over m2. So now I can plug this into here. I'll get 1 half kx squared is equal to 1 half m1 v1 squared plus 1 half m2 times m1 v1 over m2, all of that squared. This square is going to get distributed to every single term here. It'll look like this. We'll get 1 half kx squared is equal to 1 half m1 v1 squared plus 1 half, it'll be m2 m1 squared v1 squared over m2 squared. Now a lot of things are going to cancel out. These 1 halves are going to cancel out with every term. And also, one of these m2 is going to cancel. There'll be 1 at the bottom still. Now I can write this without all those canceled terms. It'll be kx squared is equal to m1 v1 squared plus m1 squared v1 squared over m2. Now I'm going to divide k to both of these terms. So now we'll get x squared is equal to m1 v1 squared over k plus m1 squared v1 squared over k m2. Now I'm going to square both sides, and we'll get that x is equal to the square root of m1 v1 squared over k plus m1 squared v1 squared over k m2. So that is your final answer. Thank you for watching.